It is time to take some notes. So open up your journals to the foldable that we did yesterday that has the 3 tabs. Yesterday we learned all about translations. You can hit pause on the video while everyone gets that out if it's not already there. So now we're going to learn about reflections today. So remember, translations, we wrote that translations are a slide. So you're physically taking something and just sliding it around the page. Now, reflections, you're going to open the Reflections tab. Reflections, remember that word rigid from yesterday? It means congruent. So that means that the size of the shape is not going to change. So it reflects. But I think it's silly to use the word reflections to define reflections. So we're going to look at it, and you see the FL inside of there. That FL is going to stand for flip. So reflections mean to flip the shape. And the shape can be reflected just like a mirror shows you your reflection. It gives you exactly what you started out with. So does a reflection. So the reflection will flip or reflect across the y-axis, or it'll reflect across the x-axis. So this is our algebraic representation again. And just a friendly reminder, if I'm writing, then you're writing. So our algebraic representation will always start with this x comma y, and then an arrow, and then here's our rule. So with dilations, it was multiply. With translations, we were adding or subtracting. And with reflections, we're just going to make it negative. But what you might notice is that the negative x, when x is negative, it means it's a y-axis reflection. And when the y is negative, it's going to reflect over the x-axis. So it's almost backwards. So if you look over here, we have the original SGS, triangle SGS. And I know that because it doesn't have the primes, or that little apostrophe. And then I'm going to look at my new triangle over here that has the apostrophes, or the primes. That's my new triangle. And what you can see is that it was reflected over the y-axis, or flipped over the y-axis. So just to show you what that means, I'm going to trace S, G, and S. And I'm going to trace my y-axis. This is my y-axis. And all I'm going to do is take my little piece of tracing paper and fold it on the y-axis. And so you can kind of see that that's my G there, and that's my, excuse me, that's my S, and that's my S. And now you can see that if I line up my y-axis, it falls exactly on top of that other triangle. And so I can unreflect it, and it goes back to where it started. There we go. And then when I reflect it over the y-axis, it falls on top of the new one. Well, unfortunately, we don't get tracing paper on star. And so I have to show you how to do it without tracing paper. So what we do is, if I'm going to reflect it over the y-axis, then you start at the y-axis and you count how far over did I go, like how many bunny hops. So G was 2 bunny hops away from the y-axis. So to get G prime, I have to go 2 bunny hops the other way, and that's where I find G prime. But the y stays the same. So it's wherever it was on the y-axis, so this was at 1, 2, 3, 4, 5, G's y value stayed exactly the same. So the point G started out at 1, 2, 3, 1, 2, negative 2, comma, 1, 2, 3, 4, 5. G prime, the y value stays exactly the same, and instead of it being negative 2, it's going to be positive 2. So that's all that changed, was we took the x and it was negative, and now it became positive. So when I say negative x, that actually means the opposite of x. So if it's already positive, it's going to become negative. It's already negative, it's going to become positive. Okay? with the reflection over the x-axis is the exact same thing. The point S here tells me it's original. Oops. They made a typo. So U prime, Y prime, and S prime. This one should just be S normal. So the S here tells me that this is the original. And then this one's the new one. And so you're flipping it over the x-axis this time instead of over the y-axis. So that means that when I trace it, we're going to be tracing the x-axis. And I'm tracing my triangle. And you always trace your letters because that's how I know what's what. And then this time I'm going to fold it on the x-axis. And that's my new triangle. So it started out here, the original, reflecting or flipping. You see how it's coming up and over the x-axis, and it lands there. If I was folding it all the way, it would. Sorry. So it lands right on top of it. Flip, flip. So notice it turned upside down. So Y, you can see Y is at the top here. When I flip it upside down, now Y is at the bottom. So that's why Y prime is down at the bottom. And you do it exactly the same way. We counted over to the y-axis. This time we're going to count over to the x-axis. S started out on the x-axis. So S prime is going to stay exactly where it was. U was 1 above, and now it's going to be 1 below. Y prime is going to be way down here, so Y started 1, 2, 3 up. So you're going to start at the axis, and you count 1, 2, 3 down, and that's where Y prime was. So Y, for example, started out at 1, 3. But I'm looking back, because I'm flipping over the x-axis, we're going to get the opposite of Y. So Y prime is going to be 1, -3. Oops, sorry. 1, -3. So the x stayed the same this time. The x stays the same. Oh no. I don't know what that was. And Y prime is going to be 1, 1, 3, -3. Remember that goes x and y over and up or over and down. So now we're going to get this other page of notes and we're going to do a little bit of practice. So if you don't already have it, you need the notes reflections, and pause the video if you need to. So notes reflections, I'm writing my name on the paper. And it says triangle ABC with vertices A, 2, 2, B, 5, 4, and C, 5, 1 is graphed below. Graph its reflection over the x-axis, then determine the coordinates of the reflected image. So I'm checking. It says A is 2, 2, 1, 2, 1, 2. Okay, so that matched. B is 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, so it is graphed. This is what they're talking about. And they want us to do a reflection over the x-axis. So if it's not labeled for you, you always know that y is up high. Oops, y is up high, and x is across. So if it helps you, write the x and the y bigger. We want to reflect it over the x-axis. So I'm going to draw a thicker line on the x-axis. I remember that's where I'm coming from. I count how far did I have to go up to get to each vertex. So from the x-axis to the C, I went up 1. So that means to get C prime, I have to go down 1. And that's C prime. And then I count 1, 2, 3, 4 to get to B. So I start back at the x-axis and count 1, 2, 3, 4. I'm going to put a dot there, and that's B prime. And then 1, 2, 1, 2. A prime. And then I just connect my dots. And hit pause if you need time to write this down. The last part said determine the coordinates of the reflected image. So I want A prime, B prime, and C prime. But I think it's easier if you write A, B, and C first, and then we write the new one. So that's what I'm going to do. So A is at 1, 2, 1, 2. And I don't know why I'm counting because it told me up here. So I'm just going to copy those from up there. A prime, B prime, C prime. They're all going to be coordinates. And so now I'm looking at my rule here. We're reflecting over the x-axis. So that means that the y is going to change. It's the opposite of y. So that means my x's 2, 5, and 5 all stay exactly the same. This one says positive 2. The opposite of positive 2 is negative 2. The opposite of positive 4 is negative 4. And the opposite of positive 1 is negative 1. So if I wanted to, I could use that rule and get the coordinates first, and then just graph it from the coordinates. So I don't necessarily even have to count. I could just get my new points first, and then go 1, 2, negative 2. Positive 5, negative 4, and graph my points that way. Okay? So now I want you to try to graph number 2 all by yourself. This one says there's a square already graphed, and the vertices are A, B, C, and D, and those ones match. And we're going to reflect it over the y-axis. And so you notice that there's an A on the other side of the y-axis, so the shape is going to end up flipping over itself. It's going to overlap a little bit. But we're reflecting over the y-axis, which is this one going up and down. So hit pause and try that by yourself, and then hit play when you're ready to check it. So if I'm reflecting over the y-axis, I count how far away from the y-axis is that point, and so A is 1 away. So when I reflect it over, it's going to be 1 away on the other side, and that's A prime. D was 2 away, so I have to go 2 on the left side now, and that's going to be D prime. C is from the axis, 1, 2, 3, 4, 5. So I'm going to start at the y-axis and go 1, 2, 3, 4, 5. And that's my C prime. And then B is 1, 2 away. So I'm going to go to the left, 1, 2, and put a dot there. So I started out with 4 vertices, and I have 4 vertices. But what did I forget to do? I have a dot here, and there's nothing next to it. I have to label it. So check your picture and make sure that there's labels on all of them, that it says A, B, C, and D, and that it has the primes, because this is my new shape. And then you can connect all of your vertices. So once again, I'm going to list my original points. Negative 1, 2, B is 2, negative 1, C is 5, 2, and D is 2, 5. So that means A prime, B prime, C prime, D prime are all going to be coordinates. This time it reflected over the y-axis. That means y is going to stay the same. So I just copied my 2, negative 1, 2, and 5. Because my notes tell me if I'm reflecting over the y-axis, my y stays the same, and x is going to be the opposite. So the opposite of negative 1, positive 1. The opposite of negative 2, or positive 2, negative 2. Did I forget a negative? Oh no. Okay, so C is positive 5. It's going to be negative